All right, so this is our T session 11 on power supplies, and let's get started. So off the bat, I'm already tired of talking, so I'm going to delegate as good teachers do, and I'm gonna have
I'm gonna let that one pass.
I'm gonna have Karen. Would you mind reading our objectives for today?
I definitely will. Objectives are identify characteristics of power supplies and its connectors, select a power supply based on given specifications, describe how to remove, install a power supply, identify common problems that will come up with power supplies and how to address them.
Awesome. Thank you so much, Karen.
No
So those
problem.
are our objectives for this lesson, and we will be touching on all four of those. But first, let's talk about our BSMs. Glean, would you mind reading our BSMs for today?
So our key BSMs are behavior, skill, communication. Behavior, skill equaling communication and mindset. You need a growth mindset for it.
Yes, absolutely. So first tip for that lab you're struggling with, communication would have been very, very helpful. And having a growth mindset is key because dealing with issues with power supplies can be very frustrating, and you have to be willing to learn from your mistakes and the challenges that you see when dealing with power supplies. I have built my computer. I've built 2 computers for myself over the past few years, and anytime there's been an issue with the build, it's been solely power supply related. So having a growth mindset is very helpful. All right, so let's talk about electricity. Let's see, I haven't heard Susan today. Would you read our first 2 points?
Sure. Understanding electricity. Electricity is a flow of negatively charged particles called electrons. The pressure of the electrons in the wire is called voltage, and it is measured in volts.
Awesome. Thank you, Susan. All right. Julian, will you read the next 2?
The pressure of the electrons in the wire is called voltage, and it is measured in volts.
Okay, will you read the 2 after that as well?
The amount of electrons moving on a wire is called current, measured in how do you say that? Amperes?
Ampere. You can just say amps. A-M-P. Yeah.
Okay. The amount of electrical power is called wattage, measured in watts.
In watts. So watts is key for us while we are working with power supplies. So let's see, Ronald, will you read our last 2 points for me?
The correlation is W equals V times A. Wires have resistance to flow of electrons measured in OHMS.
Yes, or known as ohms. So our power supplies are rated for their wattage. So I've got my current power supply box, and I might have to turn my video off for 1 second. Virtual background, let's do blur. All right, so. Oh, sorry.
You will have to turn off blur, sir, because it associates.
All right.
There you go.
So
although we can comfortably read your monitor now because that has a nice reflective surface on it.
Yeah, it does. So this is the wattage of my power supply, which should seem like a lot because it is. It's 850 wattage power supply, and it's rated 80 plus titanium. So the reason why I have this massive power supply It's because it was very difficult to find power supplies when I was searching for them. So it was either get something that is way over necessary for my build, or get something that is way under. So I went with over because that's safer. And it's pretty fancy. It's like a hybrid power supply. So if it detects that it doesn't need to be using as much power, it'll lower the amount that it's putting through. And it also has a fan in it that will activate when it's being used more intensely. All right, so let's talk about how electricity flows. LaQuisha, would you mind reading this slide for me?
Sure. How electricity flows. Alternating current, AC, oscillates between negative and positive voltage. AC travels on a hot line from a power station, then AC returns to the power station on a neutral line. The neutral line is grounded to prevent uncontrolled electricity in a short. Standard AC in the United States come in somewhere between 110 and 120 voltage. I'm not sure if that's a minus 115 back. Europe sees 220 to 224 voltage. Direct current, DC, travels in one direction and is the type of current used by most electronic devices.
Awesome, thank you so much. So this little guy here, I believe it's called a tilde, and that just means approximately, so about 115 volts AC. And so in America, we use between 110 and 120. In Europe, it's between 220 and 240. That's super important. And we'll get into that in just a little bit. So when you plug your power supply into the wall, from the wall, we have an AC current, or our alternating current, and then the power supply takes that AC current and changes it into a DC current, so a direct current, and that direct current is what powers all the components within your PC. What has been most helpful for myself and other learners when remembering which order it goes in, if you know the band AC/DC, then you have the correct order. It's the same order as the band. So AC from the wall, DC from the power supply. Any questions with that?
So the 110 and 120 volt, is it equivalent to the 220, 240 to Europe, the United
Yes.
States?
Yes.
Yes. And we'll go into that a little more in detail on the next slide.
I'm sorry, you
Gustav,
said,
Unless you're in a car, then it's DC.
unless you're in a car, sure.
you
But as
said
far as
AC from the
computers.
wall
Mhm.
and DC from where?
From the power supply.
Okay, thank you.
So the
Yeah.
power supply itself converts the alternating current into direct current because that's what is needed by the components in the computer.
Yep. Distow, did you have a question?
That was my question, but like that one's the adapter or converter. Which one is
Yep.
it to convert to the 20 to 110, between 110 to 20, working that one to Europe, and
Well-
Africa will be that 1 to 20 to 40. But mostly when I travel, I'm used to converter.
Yeah. And we'll get into that in just a second. So good addition. All right. So the power supply unit, also known as the PSU. So this is what it looks like once it is in the actual tower. So this supplies power to all of the PC components. So all these little wires that are sticking out will connect to the motherboard or directly to a component within the tower itself. And once again, it converts AC voltage to DC voltage. So from the wall, we have AC, and then throughout these wires is DC. Okay. So in America, we have 110 approximately at 60 hertz, and then 220 and 50 hertz elsewhere. On the back of your power supply, you might see a selector switch. So this little, it'll be a red switch. When you press that button, that'll switch the, that acts as that converter that Tistal was talking about. That's what tells the power supply, okay, I'm taking in 220 volts or I'm taking in 110. And so you have to make sure that the switch is set to the correct one. And I believe in 2 slides, we'll have a good image of it. But newer power supplies like the one I have has an automatic switch. So if I take my desktop to Europe and I plug it into the wall, my power supply will automatically detect that it's receiving 220 volts and it will adjust for that voltage. So I don't do anything on my end, which is very handy. But with older power supplies, and you might still see this in some, you might have to manually do it, but you should take note of it before you attempt to plug it in. And these 3 voltages are key. So you need to know, well, I guess it's technically 5, but you need to know positive 3.3, positive and negative 5 voltage, positive and negative 12 voltage. These are the different voltages that can come out of these wires. So you need to know 3.3, positive, negative 5, positive and negative 12. So if you walk away with nothing else, you need to have those numbers in your head.
And what did you say about them and the wires? Those are the voltage?
Yep, those are the DC voltages that are coming out of these wires. And you'll see
Thank you.
on the next slide a little better detail on how that looks. So our power supply provides DC connectors. So these are our DC connectors that are coming out. And once again, our capacity is measured in watts or wattages. Yes, Cynthia.
I just want to make sure, like, because the other voltages is like the plus and minus 5 VDC and then plus or minus 12 VDC, but the 3.3 is only positive.
It is only positive, correct?
Only positive, good, thank you.
All right, so now let's take a look at the inside of a power supply. When you look at a power supply and you see this, walk away. We do not touch it. We do not open power supplies ever, ever, ever. You are not an electrician.
You don't know that. Some of them may be.
Some of you may be. If
you are not a licensed electrician,
if you are not a licensed electrician, do not open up a power supply. We do not fix power supplies. I take it back. If you take nothing else from this session, do not open up a power supply.
ever.
Ever.
That is never the answer.
This can kill you, and that we just walk away from it. If you are ever asked to touch a power supply
Without the casing on it.
without the casing, walk away. That
It comes in a metal case and it is not easy to remove.
Yes.
So it's not like it'll accidentally happen.
Yes.
So as long as it's in its metal case, you're okay. It's completely covered. That's fine. But if it's opened up like you're seeing in this picture, don't play with it.
No, power supplies are known as field replaceable units. So if something is wrong with your power supply, you get a new one, you get it replaced. Why, Julian? Because of these capacitors. If you touch them, if
you ground those out, there's enough amperage in there that can fry you.
Yeah, It is
It only
very,
takes
very
about
dangerous.
1.5 to 2 amps to kill a person.
Yep.
And so those capacitors will hold enough charge where it is significantly higher than that. So the danger is just, it's too great. It's not worth it. You just don't
Yep.
take the risk.
Yep. Mark has a good point too. They hold power even after it's unplugged.
Correct. Which is why we say
Please.
hold it for 5 seconds to disperse it. And for the most part, that works. We just don't want to tempt fate and play with it just in case.
Yeah. Please stay away from the inside of a power supply. All right. So this is a little 20-pin converter or connector. It's not a great image, but this kind of breaks down for voltages in DC and how it separates it from the AC. So the power supply, the plug that goes into the wall, pulls that AC voltages and turns it into DC voltages, and it splits it up into 3.3, 5, positive. Some don't use positive, negative, but some will use both. It just depends on what the connector needs. So this one is 2 positive 5s and a positive 12. And then that connects directly to the motherboard. So what does SB stand for? Kelly, that's a question for you. I'm not sure. 5 volts SB. What FSR?
I'm not sure. Hold on. I gotta
I don't
consult my
know.
coworker. Give me a minute.
Mark, what do you mean by FSR?
I thought that was the acronym you gave. You said a power supply is considered FSR, like replaceable.
Field replaceable unit.
Yeah, it'll be like FRU, I think. But
Oh, FRU.
yeah, field replaceable unit.
FSB basically just, it's standard voltage, is a standard voltage that may be used to power circuits. I'm trying to see if there's an actual.
Okay, well, Kelly's looking at that. We'll move on
Oh,
to
it
our.
means volt standby.
There we go.
VSB, volt standby.
Volt
You will not need to know that.
No. All right, so our dual voltage option. So for those of you that are struggling with that motherboard lab, take a look at this little red button and this little IO button. Hint, hint. That might be the reason you're not getting power. Make sure your power supply is 1, turned on,
Yeah.
and 2, it has selected the correct voltage. So this is more important when you're in the States. If you come from Europe, you come over to the US and you're set for 220, but you're only receiving 115, it's probably okay. But you want to use what it's trying to pull.
If you set for 110 and you get 220,
you'll fry.
Bad things happen.
Yes, you will fry your computer if you attempt to. If it is expecting 115 and you plug it into 220, you got a big brick, a nice thick paperweight. So it should say, like this one says 230 on it. That's your equivalent to 220. On the other side, it'll probably say something like 115. And some power supplies will select the voltage automatically. Most new ones do, but make sure that you know what yours is before you attempt to plug it in. The ones in test out have the little switch. It is not automatic. Yep. Mark, I spent hours doing that lab, and then I thought, maybe it's just not receiving power. And turns out that's what it was. It's the little red switch. So
It's the little things that will hold you up every time.
every time.
It's very rarely something big. It's usually just something very little that
Yep.
you overlook, and that's what will hold you up.
Yep. Yep. Exactly, Stephen. All right. So the power switch. We have a physical switch to turn off and on the power. When it's on, it runs DC to the motherboard. So once it's pulling from AC, it converts it to DC. The on-off button on the front cover. So there should be a little square button. Sometimes it's circular. Once you press that, that's the on-off button for how you would typically turn it on. You're typically not just anytime you're turning your computer off, turning off the power supply switch. It's usually done from the front panel. And we call that soft powering off. So that sends a message to the operating system that, hey, we're powering down. Please shut down how you need to. Right. Let's talk about some cables and connectors. So this super long connector is our P1 connector or motherboard power. Okay, it's 20 or 24 pins, and it'll almost always be this super long rectangular one with a nice little cube on the side. Those are your extra 4 pins. So if you have a newer and a stronger motherboard, you might need a little more power. So you would use all 24, but older ones might only need 20. So they are backwards compatible. So if you have a newer power supply, you can still connect it to your motherboard by using the 20 pin part. And that's why it's separated between the 20 plus 4. Sometimes it won't say 24 pin connector, it'll say 20 plus 4 pin connector. But this provides the positive 3.3 volts, our positive and negative 5 volts, and the positive and negative 12 volts to the motherboard. So all the power to the motherboard, all the little powers are through here. And then you will also have a connector that is specifically for your CPU. And so this can be a 4, 6, or 8 pin connector, depending on how much power your CPU needs. And your motherboard will only have one of those connectors. So you can't plug in the wrong one. Are there any questions with these? They should look very familiar the more you work in test out, because you will be plugging them in pretty frequently. Yes, Mark.
Actually, no, I think I got it. I was gonna ask which one provides which voltage, but it's probably 4, 6, 8, and it correlates with 3, 5, and 12, right?
Yeah.
Yeah, thought so.
But also you don't need to know the voltages that are coming out of the connectors. That's not something that's required for the A+. So you don't need to worry about it, to be honest. Because you can only plug it in one way. So you can't plug it in, like you couldn't accidentally plug the 12 voltage side into the 3.3 voltage side. Right. So now we need to power our peripherals. So we have a Molex connector, which is this 4-pin connector, and it supplies 5 volts and 12 volts for IDE drives. And it would require a firm push to plug in We don't really use these too much anymore. But we also have this mini 4-pin connector that supplies 5 volts and 12 volts to floppy disk drives and fans. You see them more for fans than you will for floppy drives, unless you are working on a very old machine.
They are out there.
They are out there, but you probably won't find them in the wild too much. All right. And then our final little section on this, we have our SATA connector, which is this black connector. And this provides power to our SATA drives, so our hard disk drives and our solid state drives. We have to connect a SATA power cable as well as like a SATA data cable. And you'll see that when you work in test out as well. And that you don't really need to know the different voltages for like what wire is providing what. As long as you know 3.3, 5, and 12, you're solid. Then we have our PCI Express. So for our high-end video and graphics cards, you're going to need extra power. So you'll see 6 or 8-pin power connectors, and it'll be labeled PCIe. And like the 20+4, this one is 6+2. If you need the extra one, some even more newer graphics cards require even more power. So you might see a larger power connector, or you'll have to attach two. All right, and if you are interested in knowing exactly what voltages you're getting with each of your connectors, here's a handy little slide for you. Do you need to know this for the A+? No. I don't know what certification you would actually need to know these for, but as far as the A+
None that I have
goes,
achieved so far.
yeah, Kelly's done a lot and he hasn't had to use this information.
But it is
So there
handy to
you
be able
go.
to read a schematic.
Yeah.
And then you can also see real quickly that the color correlation matches up with the voltage.
Yep.
So you see like the orange is the +3, you have the yellow, which is +12. Black is your grounds, -5 is white, +5 is red. And then the 5-volt standby is purple. So just off of a quick glance in a standard computer, you can tell just off the color of the sheathing of the wire what voltage that is. So if you're using a multimeter, you know what you're supposed to be getting out of that wire. But that's pretty much what you'll need to know, is just be able to read the schematics. This obviously does not apply again with gaming machines, because gaming machines will put the same color sheathing over every wire, and your only hope of knowing what it is either a schematic or a multimeter.
Mm-hmm. All right, Glenn, did you have a question?
No, it wasn't a question per se. It was more of when you asked as to what those connectors would be used for, servers. Maybe,
yeah.
And for those who are working on the say on the electricity side, I know that as a technician, I walked into a house and saw a circuit board or 2 circuit boards similar to some color coded variants as to what cables were going with what and what electric parts were going to where. Mm-hmm. So this way I didn't hook up my my hub or my connection points for their satellite dish to work in that spot. But that's where you would probably need it if you were to get a server certification. That would probably be where it is on.
Cool. Thanks, Glenn. That's good information to have. Mark, did you have another question?
No, I was just curious because of the numbers you gave. Like, I know my car takes 3 pairs of the 8-pin connectors,
mm-hmm.
and it needs 450 watts of power. So yep. How do you get 450 from these small numbers that you're giving me right now?
So it needs 450 AC. it's pulling 450 watts isn't like voltages are different than watts.
Yeah,
But
volts times
it's-
amps gets you the watts.
Yeah. And so it depends on your amperage and the voltage that's required too. But since it's requiring 3 pairs of the 8-pin, I believe that it's using 450 watts. Like I believe it's making use of that. And it's converting that AC 450 number to our DCs.
I still don't get it. Do we know, is that something we're gonna learn later or is not really that important?
It's really
It's all important.
think
Oh, okay.
it's all important. Think of it as like you've got this huge tank of water, and that's like your supply of electricity. Our water is our supply of electricity. But your power supply, these let's see. These cables are your water hose, right? You're not using all of your water. You don't want it all coming out full blast from your hose, right? Because that would be way too much for whatever you're trying to water or give power. And so these hoses are what help you control the flow of electricity to those components. So that way it's making use of just what it needs. So it's almost like you're just delegating where this massive amount of power is going to, and to give it to power specific components within the whole computer.
So this VDC, I know DC is direct current. I don't know what the V is, but
Voltage.
voltage direct current. Somehow that translates into watts.
Yeah, so let's go back. So wattage is your voltage times your amperage. And so the amount of electrons moving on a wire is called our current. So your current is measured in amps. So amps is like the amount of power that's coming through. And
Okay.
it's more than you need to know as far as the A+ goes, but that's just kind of a baseline understanding. And we were here, and I'm gonna hand it off to Kelly because my voice is tired. And it's conveniently a halfway point.
All right. Yeah, I get the screen too. Awesome.
Only the best for you, Kelly.
Hey. Can appreciate that. There we go. Means I gotta stand up. Let's see here. Switch over.
You should be on slide 15.
Am I in the wrong presentation?
No, that's right.
That's the right one. Did you start a new one, Avery, or did you use the one that was already there?
I started a new one.
I'm in the wrong presentation.
Yep. So you need the ZU HG2 one.
Appreciate it. All right. There we go. That makes a lot more sense. That's not good.
That's
kind of cool. And
That's pretty normal.
it's kind of like an Etch-a-Sketch. I can kind of color it all in until we get it done. And there we go. All right, let me try stopping sharing and coming back to it. See if that helps.
That looks better.
Persistence. Here we go. All right. So moving on, form factor. Man, this just keeps coming up, doesn't it? So form factor determines the size of the power supply and the placement of screw holes and slots used to anchor the power supply to the case. So again, form factor, just a fancy name for size and shape. Also, ATX. We know that is a standard size for normal towers. That is the rectangular shaped motherboard and has more PCI or peripheral slots than your average micro or anything below that. So it's going to need a larger power supply, as well as more connectors are going to be required. Mini ATX would use smaller, mini and micros would use smaller power supplies designed for the mini and the micro themselves. If you had a micro, you might be able to get away with the larger one because they can still fit in the same case, so you won't run into the size requirements. However, the motherboard may not be able to handle it. So again, refer to documentation whenever possible to see if they will work together. All right, rails. So as computers have become more powerful and do more things and have a lot more peripherals, inputs, outputs, added functionality, drives, all that kind of fun stuff, it's going to require more power. So each rail typically in a power supply is 12 volts. And you can have multiple rails inside each power supply. So it is far more common now today to see multi 12 volt rails in a singular power supply. So you can still get the single rail, but again, like we said, more commonly you start to see the multi rails, especially as peripherals and all that stuff have a greater processing power and stronger draw of power. All right, wattage capacity. So each power supply you come across has a essentially determined output maximum for the amount of wattage that it can put out. Now, when we are selecting power supplies, we need to take into account all the components within our computer added up to make sure that what we are purchasing will be sufficient enough to power all the components that we have. Granted, we know that not all components are in use or being utilized at any given time, so it's not going to be running full bore all the time to get things done. You know, some things are off, some things are on. However, you want it to at least have the capability to cover all of those things. The wattage capacity should be listed on the documentation for your motherboard, as well as other components that you're added, so that you can just quickly add it up and make sure. And video cards tend to draw the most outside of the motherboard. And the best thing that we can say is you add everything up, add 30% on top of that. That's kind of how you future-proof yourself. For the A+, they say 30%. So this is where it deviates a little bit. Somehow I got muted. So for the purposes of the exam, 30% after you've added everything up. For real life, you probably want 50. So this is kind of where you get that deviation. You know, exam, 30%, gives you a little bit of safe. It allows you to do some upgrades, you know, and still be okay. Real life, you kind of want to go 50 because you want to get as much life out of it as you can. Yes, Mark. Did you have a question, Mark, or you just kind of?
Sorry, I didn't realize my hand was up. Let me put it down.
No worries. So they will not necessarily ask you to go through, find all the wattages, add everything up from the documentation, and then give them a number in the exam. But they may ask you, what is a general rule of thumb with regards to wattage and a power supply? Add up everything, add 30% for area plus. Okay. Go to my fancy randomizer here, a cup of sticks. See, Safal, can you please tell us what number 1 is? What kind of connector is that? All right. Safal, are you there? Right. Julian, you want to go ahead and answer that for us?
That's the Molex.
A little more
Molex
specific.
4-pin connector.
4-pin Molex. There you go. 4-pin Molex. I always find the Molex thing a little weird because Molex refers to the type of plastic that they're using, and almost all the connectors use Molex plastic.
And you will see a question on one of your practice exams that'll be it'll say Molex, and it won't be referring to this little 4-pin connector. It'll be referring to the plastic. So
Yep.
we'll come back to that
Come back to it.
when they yell at us.
All right, Leela, can you please give us number 2?
I honestly can't tell you.
Well, it's square. So
Yeah.
take a guess. I promise you we will not give you a hard time for getting it wrong. What are the main things that need power?
Wait a minute. I might have this one. No, but is this the one that supplies power to all PC components? I don't know.
Not to all PC components. That'd be a really big one, wouldn't it?
Oh, that's the other thing. Oh, okay. The PSU. Okay. Mm-mm.
So we know it's not the big main one. It's not a 4-pin Molex, which would be something like you would use on hard drives, like older hard drives. So it's got 4 pins in a square.
I don't know. Can I use a lifeline?
Absolutely. Who would you like to call on?
Steven.
A 4-pin fan connector?
Not a fan connector. We're getting warmer. It is 4 pins, but a fan connector is 4 pins straight across. This is 4 pins in a square formation.
Power.
4.
4-pin power connector.
Somebody just said it.
4-pin power connector.
It is a 4-pin power connector for the, you got a lot of help in chat.
CPU.
CPU, that is the CPU power supply. It's 4 pins in a square. And typically you would see that connected to the main power supply, but very good try.
All right, thank
Excellent.
you all.
Very good. Thank you, Lena. All right, DW. Can you please tell us what number 3 is? That's a tough one.
I can't see how many pins it has, but I'm gonna guess it's also a 4-pin connector. And I think
it is.
Is it? I can't really see it.
Well, it's got 6 wires going into it.
Okay, so it's a 6-pin connector for. All right, I'm gonna take a guess for the front panel LED for the front panel powers.
Not for the front panel.
All right,
but
let's see if I can get some help from the gallery.
Who would you like to call on?
How about Mark Lee? Probably knows.
Mark Lee.
That's funny. That's the one I said I don't know. All the rest, that one connector makes no sense to me. All the rest are obvious.
All the rest are obvious.
I'm sorry. Well, all the rest I know. I won't say obvious. All the rest I know. That one, it just doesn't make any sense to me. So if I have to guess, I'll do process of elimination since I know what the rest are. I'm gonna have to say for, I want to say a peripheral, but that's what Molex is for.
This is a tough one because it's not very commonly used.
All right, I'm gonna call your lifeline. DW is gonna call another lifeline because Hunter has his hands up. So I'm going with Hunter.
I was just gonna guess what you were gonna guess, man. Like a PCI
for the
like
graphics
connector or
card?
something. PCIe
Yeah.
connector.
Yeah, so I guess
Not a PCIe. This one, like I said, this is a tough one. This one got me. It is a 6-pin auxiliary power connector.
And that goes to what?
I guess to power other components. Some drives may use them. It's auxiliary power. It's backup.
Also, then it would also be considered peripheral, like the Molex, or no?
Yeah. Yeah, but for certain, it'd be certain types, but again, it's not a very commonly used one. So you might have to, order a special connector for your power supply for this one. As uncommon as it is. So good shot, good shot.
I'm sorry, run that name by me one more time, please, Kelly. What?
6-pin auxiliary power cable.
Dude, I don't remember hearing that one, but okay, that's nice.
All
6-pin.
right, well, we got 6 wires going into it, we can see, but it's just a 6-pin auxiliary for some peripherals, yes. Do you have any other answers there, Avery?
I put my answer in the chat.
You put your answer in the chat. There, see, rarely used anymore. Add it to the brain box. All right, number 4. We're with Solomon. Please help us out with number 4. I will give you a hint. It is a little bit of an older connector. There's Solomon. All right. Next. Julian.
Why do you call me for the only one I don't know?
Because this is the stuff that we thrive on.
I'm kidding. I have no idea.
Older tech.
PCI? No.
Not PCI. That's
Okay.
I have no idea.
Duadros is helping you out in chat.
Oh, the mini 4-pin connector.
It is a 4-pin and mini connector, most
Okay.
commonly seen in like floppy drives. So older tech.
And
on
for
that one.
fans.
And fans, yeah, I guess.
You'll see those for fans.
Yeah, the 4-pin minis, that's true. So 4-pin minis. All right. See who gets the easy one. Let's see here. Yedigishu, do you have, can you give us number 5, please?
Is that CPU power connection?
It's not CPU. It's just this one right here. This was our 4-pin that we would use on our CPU. Also, to give you a hint, this may also be connected to that. We are seeing some hints in chat. Count the pins.
Or the 20-pin ATX power supply? I
Yep.
just read from the text.
P1, or it's also called the P1 power supply. It is the primary power supply for your motherboard. So the P1. And this 4-pin right here may be connected to it. So it'd be like the 20 plus 4. So you may see that happen. Very good. Thank you, Yedigishu. Very good. Finally, Vincent, can you please give us number 6?
Is it SATA?
It absolutely is.
Okay.
That is the SATA power supply. Doesn't have the distinctive L shape of the SATA data cable, but the SATA connectors tend to have a black connector, which will help you distinguish them. So that would be for your SATA power supply for your hard drives. Very good. Here's the key. Anybody who needs it. Granted, we will have this presentation dropped student paste in the Slack channel for everybody to review again if they so choose. Lean, have a good day. All right. Oh, and we have a nice little quiz. Love these. Go ahead and